Question 2, we're now looking at some nomenclature. And in this molecule we have an aldehyde. And in my opinion at least, aldehydes are one of the easier functional groups to have to deal with because we know that the carbon of the aldehyde has to be carbon number 1. And then we can just number the rest of the carbons in this parent chain. And so we can see we have a 10 carbon chain. I'm now going to list out the names of the different substituents so that we can alphabetize those in a moment. Carbon 2, we have a chlorine. Carbon 3, we have a thiol, but remember when the thiol is a substituent, we refer to it as a mercapto. At carbon 5, we have a methyl. At 6 and 7, we have alcohols. Now, normally we put alcohols in the parent name, but because we have a higher priority functional group, the aldehyde, the alcohols become named as substituents, and we name them as hydroxy. Same thing for the nitrile. Because we have the higher priority functional group, the aldehyde, the nitrile becomes named cyano as a substituent. So now we need to alphabetize these. You got 2-chloro, 8-cyano, 3-mercapto. Oops, sorry about that. We skipped one. 6-7. Dihydroxy. Now we can get our 3-mercapto. And finally 5-methyl. Then we need our parent name, which we've numbered as 10 carbons, so decane. Because there's 2 alkenes, we keep the A. We get our numbers for the 2 alkenes, which are 6 and 8, 6,8 diene. And then the aldehyde, because we know aldehydes default to carbon 1, that doesn't need a number, it just gets the ending al. So are we done? Hopefully the answer is not yet, because we still need to do our stereochemistry. Because we have chiral centers at 2, 3, 5, and then alkenes to define as E and Z at 6 and 8. So I'm going to erase those numbers so that we can look at each one of these individually. So at carbon 2, we have a chlorine, which is going to be highest priority, and that's higher priority than the 2 carbons. And then the 2 carbons get divided up by one being bonded to sulfur, which is higher atomic number than oxygen. Our lowest priority, the hydrogen, is already pointed back, so we can just draw the arrow as is. It goes clockwise, so this is 2R. For the second stereocenter, which is carbon 3, we have a sulfur versus carbon versus carbon. So sulfur is higher atomic number. Then we have a carbon bonded to a chlorine versus a carbon bonded to another carbon. So higher priority here. Again, the lowest priority substituent, the hydrogen, already points back. So our arrow goes clockwise, so we have 3R. Carbon 5 is bonded to 3 carbons, but one of those is bonded to an alcohol, one of those is just bonded to another carbon, and the third one is a methyl. So the arrow here goes counterclockwise, but because our lowest priority substituent, the hydrogen, which is not drawn in, is pointing forward, we have to take the opposite, and so we get 5R. Now we need to do our 2 alkenes, define them as E or Z. For the first alkene, we have an alcohol versus a carbon, and on the other side we have another alcohol versus a carbon. So the alcohols are both higher priority, oxygen being higher atomic number than carbon. That means our higher priority groups are on opposite sides, so that's 6E. And finally, over here we have a methyl, which is higher priority than the hydrogen that's not drawn in. And on the other side we have a carbon versus another carbon. So we have to look at what those carbons are attached to. The first one is attached to a nitrogen, while the second one is attached to an oxygen. The oxygen is higher priority. We can now see our higher priority groups are on the same side, and we get 8Z. And so that is the full name for our compound. And now we can go on to part B. Now before we do that, make sure you read carefully in the question that part B, only looking for a common name. And part B, you can see, is one of the diacids. So those are the ones we just need to know the names of. And there's our first there's our names for our first 6 diacids. And so it's just a matter of how many carbons we have in between. This compound has a total of 5 carbons in between the 2 acids. And these just go in order. So 5 carbons matches pimelic. Again, that's the number of carbons in between the 2 acids, so what we have is pimelic acid.